Hello and welcome once again. This is an introductory lesson to integration. So we've already been looking at differentiation, or just we had a good introduction to calculus in topic 4, where we talked about differentiation as finding the gradient, or the slope, yeah, or the steepness of maybe a line, maybe a curve, yeah, finding the gradient generally. Integration is the opposite of finding the gradient. So with the gradient, we're looking for the y by the x. Now this time, we're looking for the original equation that gave us that gradient. So if, for example, you found the y by the x to be equal to 2x plus 5. This time, you're finding out what y is. What is that y is equal to something that gave you that dy by the x? So yeah, let's do this. So if we have that, if dy by the x is equal to 2x plus 4, then working backwards and thinking about how we did it when we were doing differentiation, we would imagine that y must be equal to x squared plus, there must have been an x here that we dropped off when we were finding the y by the x. That would be 4x. But it doesn't just stop there. It could also be y is equal to x squared plus 4x plus a certain number. It could be plus 5, it could be plus 7, it could be plus 100. It could also be y is equal to x squared plus 4x minus a certain number. Yeah, it could be minus 5, it could be minus 100, minus 1,000. We do not know what happens at the end there. Yeah, so we just use a letter which we refer to as c. Y is equal to x squared plus 4x plus c to represent whatever thing happens at that end there. Yeah, and that leads us to the integration constant. C is known as the integration constant, and we use it to represent that number at the end of that function there that we're not sure about, that we don't know. Whatever it is, we use c to represent it. And this type of integration, where you do not know what that last number there is known as an indefinite integral type problem. Yeah, so this is like this is known as the indefinite integral type problem. Indefinite integral. Now let's talk about the notation. Let's talk about how we represent integration. We said that we represent differentiation by writing dy by the x, okay? We can represent integration using this sign here. So for example, if you wanted to integrate x squared, you would say integrate x squared dx, which means with respect to x, okay? And if I write that in English, that means integrate x squared with respect to x. That's what that means. I'm going to write down a little formula. I'm going to write down a little formula that can help us to work out the integral each time. Yeah, and if I put that formula there, then we can use it to have a look at a few examples. Okay, so the formula for integration, let's write that down. If dy by dx, is equal to let's say x to the power of n, then y, which is the integral, must be equal to x to the power of n plus 1 over n plus 1 plus c. Now that is the formula that we need to keep at the back of our minds each time we want to integrate. Integration can be written as like this, as I told you, integrate x to the power of n dx, or they can just simply say integrate. They can say integrate x to the power of n in your question. Now here's an example. It says integrate x squared, and to integrate x squared, we could also write that this way, as I told you earlier. Yeah, and that would be equal to x to the power of 2, following our formula here, x to the power of 2 plus 1, or x squared plus 1 over 2 plus 1 plus c. And I'm just going to rewrite that as x to the power of 3 over 3 plus c. And that is the answer for that one. Here's another one. It says integrate x to the power of 8. Using that formula there, it's very straightforward. We would have that y is equal to x to the power of 8 plus 1 over 8 plus 1 plus c, which is equal to y to the power of 9 over 9 plus c. This example here says integrate 3x to the power of 4 dx. Using our formula there, we would have 3x to the power of 4 plus 1 over 4 plus 1 plus c, which we can write as 3x to the power of 5 over 5 plus c. This example says integrate 5x to the power of 8 dx with respect to x. That's going to give us 5x to the power of 9 over 9 plus c. I think you get the gist by now. Yeah, just add 1 to the power and divide it by your new power, and just add the integration constant, which is 1 with the fractional power. Is the same thing. We're gonna just add 1 to the power and then divide by the power, divide by the new power. So that would be x to the power of half plus 1 over half plus 1 plus c. And I'm just going to rewrite that as x to the power of 3 halves over 3 halves plus c. It doesn't matter if you write this as a decimal. It may show up in your calculator as a decimal, and you can still write it as a decimal, which is 1.5. It may also you may also work that out and have 1.5. I'm not going to mark, it's not going to be marked down. It will still be correct unless it specifically says in your question leave your answers in decimals. Yeah. Here's another problem, which it looks like a tricky problem. Remember, to work with differentiation and integration, you have to try and make sure that you write your numbers as powers. So once you see a root sign, what you're thinking about is how could you rewrite this root sign as a power? So the only way that you do that is remembering that fractional powers are just roots, and therefore the square root of a number is the same thing as x to the power of half. And we've already done that before. If we rewrite this as x to the power of a half, then that is the previous problem. That's the problem that we just solved now, which we had x to the power of 3 halves over 3 halves plus c. You have to remember that at all times. If you have the cube roots, that's going to be x to the power of a third. If you have the fourth root, that would be x to the power of 1/4, and so on and so forth. Now here's one with a fraction, yeah, and it says integrate 1 over x squared. Remember, we could write fractions as powers as well. 1 over x squared, or 1 over x can be written as x to the minus 1, yeah, and 1 over x squared could be written as x to the minus 2. 1 over x cubed could be written as x to the minus 3, and so on and so forth, yeah. So let's use that idea now to rewrite this as integrate x to the minus 2 dx, and that's going to give us x to the minus 2 plus 1 over minus 2 plus 1 plus c, which is equal to x to the power of minus 1 over minus 1 plus c. And we can still rewrite that as minus x to the power of minus 1 plus c, and that will be the final answer. Yeah. That's where I'm going to end it for this introductory lesson to integral calculus. Remember that that's the formula that we use, and integration is the opposite of differentiation. So whereas you're finding the gradient in differentiation, in integration you're finding the equation that gave you the gradient, the function that gave you the gradient. That's what you're looking for, and this is the formula that we use. And maybe I could leave you with one challenge problem. See if you are able to solve this one for me at home. Yeah. Integrate with respect to x 1 over the square root of x. Thank you for watching, and I shall see you in the next one. Bye.